Okay, so today we're going to do a brief lesson in fractions. Just as a review, this is Mr. Bodie's Algebra 2 class, so it will go quickly. If you're just learning, not the video for you. If you're in my Algebra 2 class and you just need to review, we will go quickly through this and hopefully it'll help. We'll start with addition. First step always should be, to check to make sure we have only fractions. We want to get rid of any mixed numbers. So down here I have a mixed number. Up here I'm ready to go. I already have two fractions with no mixed numbers. Next step, find a common denominator. I recognize that my common denominator here will be 4 times 6, which would be 24, but there's a smaller one. If I multiply this by 3 and this by 2, I can get a common denominator of 12. That would be what we call the least common denominator. Now, I'll multiply this by 3 over 3, remembering to multiply the top to get 9 twelfths. Over here, 2 over 2 plus 10 twelfths. At this point, my answer will be in twelfths. 9 plus 10 is 19. My last step is to say, can I reduce this? Well, if I can't reduce this, I can't. That is fine. That could be your answer right there. You could also change it to a mixed number if you want. For purposes of my Algebra 2 class, this is perfectly fine for an answer. Now, subtraction is going to be about the same thing. Over here, I had to use two different numbers to get my common denominator. Over here, I'm only going to have to change one of them because I recognize that 4 goes into 8. So my next step will be to multiply this by 2. And again, realizing that I had no mixed numbers to start. 2 times 1 is 2. 4 times 2 is 8. This one stays the same. Now I have 2 eighths minus 1 eighth. I kind of ignore my denominator because I know my answer will be in eighths. I don't have to do anything to it. Then I'll do 2 minus 1 and my answer will be 1/8. Okay. Looking at a little bit more complex problem, we do have some mixed numbers in these two. Addition, we will start about the same way. We're going to start by thinking about, well, what's my common denominator? I use the same fractions, so you know these will be the fractions, or the common denominator here. But before even doing that, I want to change this to an improper fraction, so that I don't have to deal with the mixed number. 1 times 4 plus 3. 1 times 4 is 4, plus 3 is 7. That goes in your numerator. Your denominator for right now stays the same. Over here, we'll just leave this as 5, 6. Now we know our next step was to change it to twelfths. So here is where you multiply by 2 over 2 and 3 over 3. This time, instead of getting 9 twelfths, I'm going to get 21 twelfths plus 10 twelfths. This will total me out to 31 over 12. That could be my final answer, as I recognize that there's no common factor between 31 and 12 that could be reduced. 31 is what you would call a prime number, so you can't divide any of the factors of 12 into that. Over here you have two mixed numbers. You're going to start out by doing the same thing. 2 times 4 plus 1, that's going to be 9. And you notice your denominator stays the same. Minus 3 times 8 plus 1, denominator stays the same. 3 times 8 is 24, plus 1 is 25. Now we need to change our first one again. Times 2 over 2. That'll give you 18 over 8 minus 25 over 8. 18 minus 25, well, I notice the larger number is second, so it's going to be a negative answer. I will have negative 7 over 8. 7 is a prime number, so you cannot reduce this, and that is your final answer. Okay, so that's a brief overview of addition and subtraction. Multiplication and division. Multiplication is probably going to be your easiest one, especially when you see something like this. Because all you're going to do is 3 times 2 is 6, 7 times 3 is 21. Now you're going to look and say, well, the factors of 21 are 3 and 7. And the factors of 6, well, 3 is a factor of 6 also, so let's get reduced by dividing by that common factor. 6 divided by 3 is 2. 21 divided by 3 is 7. Your final answer is 2 over 7. Now in my Algebra 2 class, when you look at a division problem, you will never actually do a division problem. You'll do a multiplication problem. But you will multiply by the reciprocal. This is what you're going to multiply by. So by always means that you're going to use the second one as the reciprocal. This becomes 5 over 8 times 5 over 2. 5 times 5 is 25. 8 times 2 is 16. Now I look at my smaller number and I say my factors are 2, 4, 8, and that's really it, other than, of course, 16 and 1. But none of those numbers will go into 25. That becomes my final answer. Now here, where you introduce mixed numbers, we do always want to do the same thing we did over here, where our first step is to change that mixed number into an improper fraction. So we're going to start out, we're going to do 2 times 7 plus 3. 2 times 7 is 14, plus 3 is 17. This stays, my denominator stays as 7, times 2 over 3. I don't have to convert that one. Now I look and I say 17 times 2 will give me 34. 7 times 3 will give me 21. Now 34 is not a prime number, but its only factors are the 17 and the 2.
Good morning,
and
teachers. It is now time for our Thursday morning meeting to begin. Math, language arts, foreign language,
this becomes your final
and special ed are meeting in room 109. Science, social studies, career and tech, fine arts, and counseling are in room 107. We will be beginning at 8 o'clock. Thank you.
Okay, over here you're going to convert this to an improper fraction. 1 times 5 plus 2 is 7 over 5. And I'll leave the division sign for now. Okay, I've converted it to an improper fraction, but I have not found the reciprocal. So now I'm going to go 5/8 times 5 over 7. 5 times 5 is 25. 8 times 7 is 56. The only factors here are 25, 1, 5, and none of those will go into 56. So this becomes my final answer. It's a very brief overview of fractions. If you're thinking about the steps to fractions, we always want to remember this. 1, change to improper fractions first. Okay? Always change to improper fractions first. It's going to help you a lot. The last step on everything will be step 4, and that will always be to reduce. We didn't have to do a lot of reducing here, but we did have one example. You're always going to have to reduce. What's going to change are steps 2 and 3. If you're adding and subtracting, step 2 should be find your least common denominator. If you're multiplying and dividing, well, if you're multiplying, let's go with just that. Multiply straight across. Okay? Now if you're dividing your second step, or third step in this case would be, or dividing would be find reciprocal of second fraction. And step 3 really on add subtract is to add your numerators, remembering that the denominator doesn't change. The multiplication, there's no third step really, because all you're going to do at that point is go straight to step 4. And division, this is where you multiply straight across. Okay, so the keys in this are changing to improper fractions, being able to find the least common denominator, and a reciprocal. And then remembering multiplication straight across, numerators and denominators. And if you're adding or subtracting, you're going to add or subtract just the numerators. Final step, reduce. That's a brief 10-minute overview of all the different operations we will use with fractions.